Alright, so open up the rock, paper, scissors project from section 6 and let's see how the remainder operator can help us to check who won. Alright, what I'll do is I'll add some comments next to the constants up here on starting on line 7 to show what beats each one. So on the first one, for rock, we're going to put beats scissors. And in parentheses, it's going to be scissors plus 1, remainder 3 equals 0. On the next line, I'll just tab that in a little bit so it's a bit more aligned for us. And the next one's going to be beats rock. And the code for that's going to be parentheses rock plus 1 parentheses remainder 3 equals 1. And the third one is going to be beats paper, and parentheses there is going to be paper plus 1 parentheses remainder 3 equals 2. So we know that rock beats scissors. Looking at the comment on line 7, scissors has the value 2. If we add 1 to it, we get 3, or 2 get 3, then taking the remainder after dividing by 3, we get 0. For line 8, doing the same thing for rock, gives 0 plus 1 is 1, 1 remainder 3 is 1. And for line 9, paper plus 1 is 2, 2 remainder 3 is 2. By applying that calculation to the computer's choice, we know then that the computer has lost if the player has the same value. And we'll still need to test for a draw, of course, but that this complicated expression down here on lines 66 through 67 can basically be replaced. So I'm going to comment those two entries out. And what we're going to do instead, I'm going to change that to else if, and parentheses, player value is equal to, two equal signs, parentheses, computer value plus 1, parentheses, and then the remainder operator, 3. Then parentheses. So again, it's else if player value in parentheses is equal to parentheses computer value plus 1, closing parentheses, and remainder 3, then a closing parentheses. All right, so let's try running that. So into rock, paper, or scissors, we'll try rock first. Computer chose rock, player chose rock, it's a draw. Yes, we'll play again. We'll try paper this time. Computer chose rock, player chooses paper, player wins. Yes, we'll play again. This time we'll choose scissors. Computer chose rock, player chose scissors, the computer wins. Would you like to play again? No. So looking at that code, you may still decide that the else if condition was more readable, and that's fine. When you write your code, write it in a way that makes the most sense to you. We're showing techniques that may be useful or that you may find in code that you have to work with. Before I finish, that condition, which you can see now on line 68, helps us to demonstrate why the equality operator, the two equals, has lower precedence than the arithmetic operators. Everything on the right-hand side of it must be evaluated in order for the condition to work. If you're still not sure, consider what happens when I use parentheses, again on line 68, to force evaluation of the equals before the remainder operator. So we add a parentheses there and add the other parentheses here. We actually get an error, which isn't surprising, and if we highlight it, breaking that expression down into its sub-expressions, we have computer value plus 1. So let's say that evaluated to 2, any value would do for this discussion, so I'm going to pick 2. Next we have player equals 2, assuming the value 2 for computer value plus 1. So that's going to evaluate to either true or false. Whichever it is, we're then going to perform the remainder operator on it. True remainder 3 is obviously nonsense, and that's why the code won't compile. And you can see there it says operator remainder cannot be applied to operands of type bool and int. All right, so I'll undo that change. All right, so we'll finish the video here, and in the next one, we'll have a look at the remaining relational and conditional operators.